Vehicles have some speed limits when they are traveling on a rough curved surface. So above figures show the vertical sections of a vehicle on a rough curved road of a radius r and bank angle theta. When the vehicle is moving with the most safe speed, which is equal to square root of rg tan theta, only two forces are acting on it. One is its own weight mg, which is acting downward, and second is normal reaction, which is perpendicular to this horizontal surface of the road. And the centripetal force is always acting towards the center, which is get balanced by the horizontal component n sine theta of the normal reaction. But in reality, the vehicle never travel exactly with the same speed. The speed may have lower limit or the upper limit. Let us calculate the value of speed which is less than most safe speed, that is v1 less than square root of rg. These are the vector diagrams for a vehicle which is moving on a rough curved road. In this case, the direction of force of friction Fs between the road and the tires is directed along the inclination of a road in upward direction as shown in figure. Also, this Fs component is resolved into two components. Vertical component is Fs sin theta and horizontal component Fs cos theta. Also, we have resolved the normal reactant into its two components, vertical component n cos theta and horizontal component n sin theta. Here we have considered that the velocity is or the speed is less than the most safe speed. So it is found that the centripetal force must be less than the horizontal component of the normal reactant n sin theta. For the speed other than the most safe speed, the component of the force of static friction, that is Fs sin theta and Fs cos theta, which exist between the tire and the road, they help us in a certain limit. From the given vector diagram, it is found that Fs cos theta is parallel and opposite to the centripetal force vector and n sin theta vector, which take care of the necessary centripetal force. So from the diagram, it is found that mg vector balances two parallel vectors Fs sin theta and n cos theta. So we can make a equation 1 as mg is equal to Fs sin theta plus n cos theta. Also, the vector Fs cos theta balances two parallel vector. One is Fc centripetal force and another is n sin theta. So we can write the equation as Fs cos theta is equal to Fc plus n sin theta. Substitute the value of Fc, that is n v1 square upon r, and rearrange this equation. We can write m v1 square upon r is equal to n sin theta minus Fs cos theta. Now let us divide the equation 2 by 1. We can write here m v1 square upon r into 1 upon mg is equal to n sin theta minus Fs cos theta upon Fs sin theta plus n cos theta. Here we can cancel out some term from left hand side. We know that frictional force depends on the speed of a vehicle for a given road surface and the tire of vehicle. So we can write the frictional force is directly proportional to the normal reactant. By taking the constant as a mu s, that is a coefficient of static friction, we can write the equation as Fs is equal to mu s n. By considering the equation 3 and cancel out the common term from the left hand side, that is m is getting cancelled out, and we will divide the equation 3 by n cos theta to remain the value same as of equation. We get the equation as v1 square upon rg is equal to n sin theta minus mu s n cos theta upon n cos theta divided by n cos theta plus mu s n sin theta upon n cos theta. As we divide this equation by n cos theta to the numerator and denominator, it does not change the value of the equation 3. Now just separate this terms and find out n sin theta upon n cos theta. Here n will get cancelled out and you will get the value as a sin upon cos theta, and we can write down the tan theta term here. Next term is mu s n cos theta upon n cos theta. N cos theta will get cancelled out and you will get the value only as a mu. So numerator can be written as tan theta minus mu s. Same thing in a denominator. Separate the values. N cos theta upon n cos theta. This will get cancelled out and you will get the value is 1. And mu s upon n sin theta upon n cos theta. Here the n factor will get cancelled out and you will get the value as a mu s sin theta upon cos theta, which we can write down as a mu s tan theta. So we get the equation as v1 square upon rg is equal to tan theta minus mu s upon 1 plus mu s tan theta. Rearrange the term and we can write here v1 square is equal to rg into tan theta minus mu s upon 1 plus mu s tan theta. So the value of a speed can be written as square root of rg into tan theta minus mu s upon 1 plus mu s tan theta. So this is a speed which is less than most safe speed. Thus, the value of speed less than most safe speed can be written as v minimum is equal to square root of rg into tan theta minus mu s upon 1 plus mu s tan theta. In this equation, if the mu s value is equal to or greater than tan theta, v minimum becomes 0 as numerator value becomes 0. And this is true for the most of the rough road bank at smaller angle.